So now we've moved on from the study of one-dimensional motion of Chapter 2, Motion along a straight line, to now two- and three-dimensional motions, motion along curves, motion of projectiles, objects in circular motion, and such. Mostly we'll be looking at two-dimensional problems. And as before, we'll begin by looking at those two-dimensional problems with constant acceleration, especially one in particular type of two-dimensional constant acceleration problem, projectile motion. But for the two-dimensional case, we just have two sets of constant acceleration problems, equations. In the x direction, and the same set in the y direction, corresponding set. And specialized to the case where for projectile motion, well, what do I mean by projectile motion? Better clarify this first. Have an object, for example, on the ground, a rocket or something, and it's fired into the air, for example, at some angle, and after that it's not acted on by any other forces other than gravity. This is a projector. And for this motion, as will become clear later when you study dynamics, the acceleration, the x direction, is 0. The acceleration, the y direction, is minus the acceleration of gravity, minus 9.8 meters per second. So for projectile motion, what do we have? Just to this is the only really relevant one for the x direction, and the y direction I should say the velocity in the x direction. So there's no acceleration, the velocity remains constant. Projectile motion problems should be exercises in one, translation and algebra. First, in translating the word problem into a mathematical notation, then solving the resulting system of equations. For example, let's look at number 3.9 from the text. Let's see. Here we are. Physics book slides off a horizontal tabletop with the speed that's given. Make sure that we have annotation. Yes. So the speed is given. Strike the floor in so many seconds. We want to ignore air resistance, which we normally do, and we want to find the height of the tabletop above the floor. Let's be sure that we have the right picture first. Have some tabletop, have some height, some things we want to find. And the book comes off horizontally, as it naturally would, with some initial velocity. This distance then will be x. It's important to decide on where you want to locate the origin for your coordinate system. You can either choose it at the ground in this case, or at the point where it jumps off the table, or just choose it at the ground. Right. And so, what do we have? Given the time, the initial velocity in the x direction, it comes off the table horizontally, so the initial velocity in the x direction is just the velocity that they give, and that tells us that the initial velocity in the y direction is 0. We're also given that in words, and now we want to write it, express that mathematically like that, and we want to find what? The height of the table and the range, x. Given what? Given the projectile motion equations. And I'll write it this way. Take the y0 to the left-hand side. And so just put in the initial velocity, 1.4 meters per second, the 0.32 seconds, and delta y. The initial velocity in the y direction is 0, so this is minus 1/2, 9.8, 0.32 squared. What we've done there actually is to locate the origin at this point. We get a negative delta y, it falls down. What are those numbers? Let's go ahead and check it. So for the range, looks like we had a 1.4 times 0.32 in meters, so 0.448 meters. And for the height of the table, what was that? Yes, 9.8. 0.32 square, all of that divided by 2, so 1/2 of a meter. So there.